from
Sorry.
from speaking from Brisbane, but I'm actually an emeritus professor at James Cook University, and Max Nine was a graduate student of mine that I supervised working on the sediment system I'm going to talk about today. So he's contributed quite a lot to what I'm going to talk about. Okay, so this is a very unusual setup. You will have all read the title by now, so I won't bother worrying about that. You've all seen it, and we'll just go to the first picture. And here we are. So the sediment system I'm talking about is shown here in black. It's the Campaspe formation, which is it's about a bit over 100 meters thick in some places, many places thinner. It covers quite a substantial area, as you can see here, and it's sort of perched in the landscape, and which is pretty unusual because it's quite young. It's a bit over 3 million years old. It's Pliocene, and you'll see the evidence. I'll show the evidence for that for the minute. And it's you can see up on the northern side here, it's bordered by the Bertigan River, and in the present day environment, the Bertigan River carries a huge sediment load, and the Bertigan River continues down here as a tributary, comes down here, the Sutter, and it delivers a huge volume of sediment down here. And in the present day landscape, it actually builds a big sand spit out here at Cape Bowling Green. So, the Bertigan River and its catchment is quite efficient now in taking sediment to the coast. So why is it in the Pliocene it wasn't? And we've got this sediment system perched in the landscape. So that's what this talk is really all about. Okay, so let's have a look at the setup. so here's Charters Towers, and you can relate this to the map we just saw, and that's the outline of the Campaspe, and its upper surface of the Campaspe formation is called the Campaspe surface because it's actually an alluvial plain, and we'll look at that in some cross sections in a minute. But just looking at the context of the Campaspe in terms of other rock systems around, if we look over here, we can see the grey. That's Paleozoic bedrock, a bit heterogeneous. There's a basin system down here, a late Paleozoic basin system, and there are a whole bunch of granites and other things, all Paleozoic though. But we've also got an early tertiary sediment system, which is left as relicts, and it's got ferricrete development on top of it. And it's shown in these little black spots you can see here, and you can see other bits here just west of Charters Towers and to the north of Charters Towers as well. So that's a relict early tertiary sediment system with jury crust, mainly ferricrete sitting on top of it. And all you folks will be well familiar with jury crust and ferricrete. And in addition, and this is important, up in the northern part of the Campaspe here, it gets tangled up with basalts of the Nulla basalt. So that's a basalt system which is quite enduring in age, and part of it is quite young. One of these flows here is only about 20,000 years old, which is pretty remarkable but it goes back into the Pliocene and even earlier. So that's the setup. Now we'll just look at some profiles that I've drawn that run across the Campaspe surface. There's two up here and two down here, which will give you a feel for what the topography is like. And there are also a bunch of seismic lines that have been shot. They were shot by Shell across that Paleozoic basin I was talking about, the Drummond Basin, because in a wild fit of fantasy, Shell thought that the Drummond might have hydrocarbons. But anybody with any sense and any knowledge of the Drummond Basin would think that's fantasy, which it turned out to be. But they're useful seismic lines because they go across the Campaspe surface and it's actually registered on those lines. And in addition, on this top line here, there are a number of drill holes. So, if you think you can see the Campaspe surface in the seismic profiles, you can confirm it by looking at the records of these drill holes. And we'll look at that in a minute. So just looking at those profiles across the Campaspe, there are two here in the north that are sort of running west to east, not directly, but southwest, northeast, northwest, southeast. This is where the Campaspe is covered, particularly in this first profile here. It's actually covered by the Nulla basalt, but its extent is really shown here by these arrows, and it goes for tens of kilometres. It's quite a substantial extent, and this line here, this profile here, again, that's the Campaspe distribution, and across to about here, it's covered by Nulla as well, Nulla basalt, and then it pops out as the Campaspe surface down here. It's got a little bit of relief in this northern part, and you can see that the topography is dropping and the drainage is dropping from west to east towards the Burdekin River, which is over on this side. Further south, here's a nice profile across Campaspe, northwest to southeast, and you can see this is the southern part of its distribution, and you can see a nice gradual gradient here of 400 metres or so across probably 50 or 60 kilometres, or even a bit more, of the distribution of the Campaspe formation across to a tributary of the Burdekin River, which is across here now. And here's one that is sort of running across the flat of the Campaspe, and you can see it's a flat planar surface rising on both sides in this profile to bedrock. This bottom profile here shows the seismic line, one of the seismic lines that I pointed out just a minute ago, and you can see the Campaspe clearly recognised on the seismic line. And here's a drill hole here, which has recorded the Campaspe and its base against bedrock. So we know that this really is the Campaspe that we are seeing in the profile. Okay, so now let's just have a look at outcrop. I should probably back up here and point out up here the best outcrop of the Campaspe. It outcrops very poorly because it's the current land surface, and it's got soil and grass over most of it. But there's a nice outcrop here. Best outcrop is actually at Red Falls, which is just where my cursor is pointing now. So this is the Red Falls outcrop, and here's the Campaspe. here's a couple of no-hoping geologists here, me and Max, I think. I can't quite pick us out because the images are too small. And the Campaspe here is about 10 metres thick, and it's covering that jury-crusted surface. Ferrycrete here, a ferrycrete developed on this older Southern Cross Formation, which is early Tertiary in age. So that's the best outcome. So let's just have a look at what the Campaspe looks like when you can actually see it in outcrop. And it's all sandstone, as you can see, and it's got crude bedding, not very continuous, not very well developed. It looks as though it's probably some sort of a fluvial system, but not a very well organised one. That's me when I was quite a bit younger, I'd have to admit. And here's the ferrycrete that's covered by the Campaspe down here. Okay, so let's just look at what control we've got on the age of the Campaspe. And the age is provided by potassium argon dates on basalts of the Toomba basalt. And you can see an older one down here, older Pliocene at 3.62. There's one that's actually in the Campaspe at about 3.5, and there are a couple of younger ones up here, the oldest of those at about 2.4. So it's pretty clear from this data that the Campaspe age is about 3.5 million years ago, late Pliocene. Okay, it's all of a pretty convincing story. Now, the bedrock in this general region is mineralised. Here's Charters Towers, and Charters Towers, late last century and early this century, was an amazingly productive goldfield. It was, it was a feature of world gold production. It had its own stock exchange. It had lots of pubs, and the town's still there. It survived after the gold was gone, but quite a few of the houses at Charters Towers were actually put on the back of drays and moved down to Townsville and are still in existence, as well as what's at Charters Towers itself. Further south, there's a mineralised belt of bedrock, which is early Paleozoic. It's a 70-mile range group, which I worked on in a previous life, and it's known to be mineralised, and it's striking this way, and it's heading underneath the Campaspe over here. Now, mineral companies, in their lack of wisdom and great optimism, decided that maybe somewhere underneath this Campaspe cover there are valuable resources waiting to be found. But how are you going to find them? So they decided, and several companies, they must have been fairly devoid of ideas, I think, but they decided what they'd do is pattern drill the Campaspe along the line of this mineralised area to the south and to the west of Charters Towers here in the north. So that they'd pattern drill and sample the bedrock and see if the bedrock had any mineralisation to show for itself. Okay, so here's the let me just go back and the rectangular to square areas you can see here are the areas that they percussion drilled, and so the pattern drilling to basement was not 10 or 20 or 50 or 100. It was about 2,000 percussion holes, and they were typically spaced about 1 kilometre, and they're on an east-west and north-west and north-south grid. And these spots you can see in these areas identified on the previous slide are the location of drill holes. And the drill holes record the altitude and also intersection with basement. So they show the thickness of the Campaspe. So you can use that data, which I've done, to contour the thickness of the Campaspe. And it ranges to 100 metres, a little bit more, generally thinner, mostly somewhere around here, 50 or 60 metres thick, but still a sizable body of sediment. And we can sort of pick out the drainage a bit up here. We can see the drainage. Well, you can see that there's a buried landscape underneath the Campaspe surface. That's what comes up from these drilling records. So the buried landscape is shown with these contours here. Okay, so that's pretty unusual. Usually you think sediments are developed in basin systems that have got pretty flat floors, but that's not the case here. There's a buried landscape underneath the Campaspe, and the drainage you can see in that buried landscape, at least in here, is sort of heading towards the Berdigan, and particularly down here, it's heading eventually to the Sutter and then into the Berdigan. So it sort of mirrors, to some extent at least, the present day drainage pattern. But that is quite a remarkable record, I think, unique to my knowledge in Australia, of actually having this drilling record showing this buried landscape underneath the Campaspe. So we can just look at some profiles up here in the north and down here in the south across the Campaspe. They're east-west profiles, and you can see up in the north, here's the Nulla basalt, and here's the Campaspe underneath. Here's the bedrock, Paleozoic bedrock. A bit further south, same thing, a bit of Nulla, bedrock, Campaspe, and two more further south. All of these profiles are in the area of pattern drilling, and the location of drill holes is shown by these dots across the top of these profiles here. So it's pretty well controlled, and you can see the relief on this paleo buried topography is quite substantial. It's 50, 100 meters, perhaps a bit more in places, of topography which has been buried. A very unusual circumstance. Okay, so what's the Campaspe like as a sediment system? And we've got the outcrop at Red Falls, which is about 10 meters thick, that you can log an outcrop, and you can see there are a few bed forms in here that can be distinguished a bit, but there are other fully cored holes through the Campaspe that allow us to see its character more extensively. And one of these holes, this one here, is almost 100 meters thick, a core to log. So Max, my graduate student, did this. He logged these cores, and you can see that the Campaspe is made almost entirely of sandstone. A little bit of conglomerate here and there, a little bit, not much, of siltstone here and here, but pretty much all sandstone, and ranging from medium grain to coarse grained. because the side, the width of these blocks here indicates the grain size of the sandstone. So it's a sand system basically. And you'd think, farmers would be pretty pleased about this, you would think, because you would think they'd be able to sink boreholes into the sand system and pump out any amount of groundwater. But that's actually not the case, as we'll see for a reason in a minute. So the sandstone in many places is a bit pebbly, as you can see from these notations along the side here. Mostly Paleozoic pebble bedrock, but ferricrete aggregate in some cases as well, such as here, up here. Where else? Oh, down here. So ferricrete aggregates. So that's a bit of that ferricrete surface I was talking about, developed on top of the Southern Cross Formation that has been eroded and reworked into the Campaspe sediment system. Okay, so it's and we've sampled, or Max did this. He sampled the Campaspe at a horizon shown by these little triangles, so quite a few samples, and then he analysed the sediment to determine, first of all, the grain size and its character, but a little bit more than that as well, because he looked at the makeup of the sediment in terms of grain composition. And you can see here that quartz and cryptocrystalline silica make up most of the sediment. Okay, absolutely dominates over here, a little bit less so here, a little bit of quartz feldspar lithics, shown by this greeny colour here, but a persistent presence of ferricrete aggregates as well as framework grains, and you can see they're quite prominent in some samples, and there's a persistent presence, as you can see by the little purple bits that show across here. So a lot of the samples actually have this reworked ferricrete covering developed on top of the Southern Cross Formation, reworked into the Campaspe system. So, what can we conclude from this? Well, what we conclude is that this sediment system was developed off a very deeply weathered landscape. Okay, so all the labile components of bedrock in the landscape have been taken away, and we're left with predominantly just quartz and ferricrete aggregates. Okay, so it's it was a landscape deeply weathered, ripe for erosion and the development of a sediment system. That's for sure. Okay, so let's just have a look at what the sorting is like in those samples that Max took of the Campaspe, and you can see that the sorting in the samples he took is a good deal less than average, very poorly sorted for most samples, a lot poorly sampled, moderate sorting, just one. And here are the lithologies over here, very fine sand through to granule gravel. Okay, so it's texturally, it's a very immature sediment system. Okay, Now, Max prepared some thin sections, and here they are, and you can see that it's a grain working in terms of rounding is virtually non-existent. So these grains are just fresh out of the regolith into the sediment system, virtually no reworking. We know it's compositionally mature because all the white stuff you can see here is quartz. There are some ferricrete aggregates as well, like this grain here. So texturally very immature, angular grains, and a mud matrix is actually common. So that's where we look at this as a sediment system, fluvial sediment system, and say, well, there's all the sand. Where's the mud? Well, a lot of the mud is actually mixed up with the sand. It's interstitial in the sandstones. So, what can we conclude from this? Well, what we can conclude that the Campaspe was a product of mass transport and very limited sorting and no grain rounding. Okay, so it's a very immature fluvial sediment system. So, how does that work? Uh, why didn't all the sediment, get down here into the Burdekin drainage and get delivered to the coast, like as is happening presently? Right? Here's a bedrock over here, delivering the sediment, a deeply weathered bedrock surface and ferricrete surface, delivering sediment, right, down to the Burdekin or towards the Burdekin. I guess some of the flow made it to the Burdekin, but it's quite clear that a lot of the flow in the landscape never made it to the Burdekin system, never got to the coast. It actually got stranded in the landscape in these distributary delta systems you can see here, and that is what formed the Campaspe system. Okay, so clearly a very different climate system from the one that prevails today. Okay, so and the thinking has to be, well, my thinking has to be that it's a very arid climate setup with episodic flash flooding, where the stream capacity didn't have the carrying capacity to get the sediment to the coast. It just left it in the landscape. Okay, so incompetent stream power that just didn't facilitate sediment transport to the coast, and the sediment got stranded in the landscape. So that's the storyline. Let's have a look at how that climate setup might relate to what we generally see in other parts of Australia. And this is a compilation from or a diagram from Rhodes et al. 2005, and these folks did OSL, optically stimulated luminescence, on the dating of landscapes. Okay, and so they worked out from that data set that here's desiccation here with early gibber formation at about 4 million years ago, extending through to widespread gibbers Gibber Formation in the land about 3 million years ago. Here's the age of the Campaspean here. Okay, so what we see or what we infer for that arid landscape subject to periodic flash flooding, it fits with what we know of Australian climate at that time. Okay, so it's got a climate record which is fairly unique as far as I know in Australia, because I don't know anywhere else where that's actually been documented. Okay, so that's the that's the end of the talk. So if you've got any questions, perhaps I can have them.
Wonderful. Thank you so much, Bob. That was fantastic. And I actually really enjoyed hearing it the second time around. 'Cause I was a bit
Good.
tired the morning I flew over to the conference. So that was great.
Oh,
Thank
good.
you.
I was
Do
happy
we
we
have any
got there.
questions in the audience? Yeah, no. I had faith. I had faith. If anyone's got any questions, I'd like to pop onto camera and turn your mic on so we can have a bit of a chat. There's not too many of us, so I think we could be pretty organized about it. Oh gosh, they're all shy.
I guess they're
I'm
all
not.
sure.
I was just wondering. They're all shy, but I'll ask a question if you'd like, Bob. I was wondering, you know, given this was, I mean, a lot of this, the early kind of data gathering was done quite some time ago, and I guess, you know, like you
Yes.
say, by mistake, some of it as well. Is there anything that you think that you would still take from this study to use in another study, or is this the type of opportunistic research which, you know, often has some really great surprises that's hard to
No,
replicate?
it's just optimistic research or opportunistic, as
Yeah,
you say. And
yeah,
I
yeah.
got those drilling records together and contoured that buried landscape. So and I did that fairly recently. This work's actually published in the AJES a few years ago.
Mhm.
So if anybody wants to look it up, they can.
Yeah. Yeah, I think it's I actually was sitting inside in a basin prospectivity group for a little bit here at the Geological Survey in South Australia. And part
Yeah.
of that was that I sat in on some workshops where they're doing their play mapping, which I, you know, which is actually not that far removed from some of the work we do with regular landform mapping, right? So, and I found that really interesting because it's looking at those contours from your drill logs. I'd never done it before, even though I'd worked in mineral sands and other things, like that connecting the
Yeah,
dots
yeah,
across
yeah.
that sort of those different depth slices, and it was really useful. Yeah, I
Bit of
found
an
that really
idea
interesting. It made
there.
me think. Yeah, it made me think about the sort of opportunities we might miss with you know, we try to stick with these methods that we think we need to do, but I know there's lots of spaces and like lots of basins in South Australia that perhaps just pulling together some of that play mapping or like what you've done with this mapping through the different drill logs might bring out some
Yeah,
really interesting stories for that
yeah,
paleo environment, especially on the basin
yeah,
margins. So
yeah.
yeah, that's
Interesting.
great.
Oh, good.
Yeah, I've got a question. Got a question from KP10.
Ah,
Any placer gold in the sedimentary rocks? Did you?
no, they found nothing. So God knows how much money they spent on those 2,000 percussion holes. I hate to think, you know, I think it'd even make Gina Reinhardt blush. Yeah,
I'm sure someone could probably like do a bit of a sum on it. Yeah, but I mean, percussion's the cheaper option, isn't it? It's just the actual scale
yeah,
of it that
it's
makes
a
it
cheaper
expensive.
drilling option, but
Mm.
it still costs money.
Oh yeah. All right, I've got a question from Steve Lewis at GA as well. Thanks, Bob. Excellent presentation. You briefly touched on the groundwater system in the region. Can you elaborate a bit more about why the Campaspe Formation is not a good source of groundwater supply to pastoralists?
Yeah, it's very tight because it's got all that interstitial clay. So it's got all the fines, you know,
Mm.
so it just won't run water. It's because of the interstitial clay. So it looks
Yeah.
good, but it isn't.
Oh, that's a great reason why it wouldn't be very good water source. Yeah, fantastic. Does anyone have any other questions in the audience?
All right.
I think my internet's playing up a bit. Hopefully I don't lose you guys. No, no more questions? Anyone have any comments or like to talk about any of the things that they've sort of the work they might have done or anything that sort of reminds them of something they've done? Like a very quiet audience today. It must be lunchtime in a few places, I think.
Must be thinking about the sandwiches.
Yeah. From sand to sandwiches. Yeah.
Yeah, yeah.
Oh,
Well,
fantastic. Well,
I'm,
yeah. Well, like I
I'm,
guess people know where to find you, Bob. So if they wanted to drop you an email, I'm sure you might get some questions after the talk today.
no problem.
Yeah, and this video will be available on our YouTube page. If people are interested in finding out more about these webinars and as we have them, please drop us a line at regolith secretary@regolith.org.au, or perhaps myself. It's pretty easy to find us. We're the Australian Regolith Geoscientists Alliance Specialist Group through the GSA, or ARGA, we like to call ourselves. And if you're interested in joining or getting the newsletter or anything like that, or perhaps even giving a webinar, please get in touch, because we love these chats and we love bringing people together to talk about regolith and all things close to the surface, perhaps, and weathered or transported. So great.
Good.
Thanks so much, Bob. It's been a pleasure to have you here today.
Okay, thank you. I've enjoyed giving it. Cheers.
Yeah, it's been great. Thanks, everyone. Thanks for joining us.
Yeah, yeah. Bye
And have
then.
a lovely
Bye.
afternoon
Yeah,
or the
bye.
rest of your morning.
Yeah, yeah.
Thanks, Bob.
Cheers.
Oh,
Cheers.
I'm gonna stop.